Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Cindy. And you can contact Do the Math if you're in Bakersfield and you need homework help. Call 636-4357, toll free 1-866-636-6284. You can email us at dothemath@kern.org, or you can also go online, dothemathonline.net, and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, so a variety of ways to get a hold of us here at Do the Math. Do remember we have phone tutors available on most Tuesdays and Wednesdays throughout the regular school year between 3:30 and 5:30. And we have a very special guest in studio today. We'll get to that young lady in a few moments. But first, I would like you to work on a problem that I know a lot of middle school students are working on. Okay. So this is an equation that a lot of students are working on. So we'll start off with this. 55 is equal to 3, open parentheses, 2n minus 1, close parentheses, plus 2, open parentheses, n plus 5, close parentheses, and solve if you would please.
Okay, so we're basically trying to figure out what value n will be so that this whole thing, when we do order of operations, would equal 55. So we're going to use a distributive property, 3 times 2, which will give us 6. So this is going to be 6n. 3 times -1 is -3, so we simplify that part. And then we want to also simplify this part so we can get rid of these parentheses, and since we don't know what n is, we can't just add this up. So 2 times n is 2n, and then that counts as a positive, so this is still positive. Positive 2 times positive 5 is positive 10. So right now it looks like that, and it's still equal to 55 on this side. So when we look over here, we have a whole bunch of stuff. So we're going to go ahead and we're going to combine our like terms, the things that can go together. So 6n and positive 2n will be 8n. And then -3 and positive 10 will be positive 7. And 8n plus 7 will be 55. And then now we're just at a basic two-step equation. So we're going to get the n by itself by getting rid of the 7 first. So we do the inverse or opposite operation. So we're going to subtract 7. And whatever we do to one side, we have to do to the other side. So we're going to keep the 8 in there. And we're going to do 55 subtract 7 is 48. And then this says 8 times what is 48. So we divide by 8. And we get 6 equals n, which is the same thing as if we set n equals 6.
Now, a lot of students will do that exactly the way you did it. Mm-hmm. But if they're taking a test and they want to know what their score would be when they turn in the test, how can they verify that 6 is the answer?
Okay, so then they just want to go ahead and they want to check their answer. So they want to take their value that they got, so 6, and they want to plug it in and then work this side out and make sure it equals 55. So let's see. They would do, so they're going to check it. It's supposed to equal 55 when they do 3 times 2, but instead of n, we're going to go ahead and put 6. So 2 times 6 minus 1 plus 2 times 6 plus 5. So I'm going to go ahead and move that up some more now that I wrote it down. Okay, so instead of distributing, now we're going to actually just do order of operations. So we'd work inside our parentheses, and we would do our multiplication first. So this part's 12, and then 12 minus 1. All of that parenthesis equals 11, and there's still a 3 out here, which means 3 times the answer. Okay, 2 is going to multiply with the answer from this parenthesis, which is 11. So 2 times 11. And then we're going to go ahead and do 3 times 11 is 33. 2 times 11 is 22. And then we finish it by adding, and when we add, we get 55, which is exactly what we were supposed to get. Right here, we had a 55. So then we know our answer's right.
All right, nicely done. Thank you very much for that, and hopefully that helps a lot of the students at middle school working on equations right now. Time now for today's Math in the News. Well, in studio with us today, we are very pleased to announce that we have CSUB President, Dr. Lynette Zelezny. How are you today?
Thank you, Michael. Wonderful to be with you today.
I'm awfully glad that you were able to take some time, because being able to schedule different people, because you are a very busy young lady, all around Kern County,
Thank
and
you.
especially out and about doing things with a lot of students. One of the things that I wanted to talk to you about is because you were recently spotted in the newspaper greeting students from BC
Yes.
at CSUB.
Absolutely.
So can you talk about that collaboration a little
I'm
bit?
so pleased to talk about that. And I'm happy to announce that that is a wonderful collaboration between Bakersfield College, Southwest, and CSUB. We have about 2,000 students. Most of those students are associate degree transfers, and they will be doing 2 years of work at BC on our campus, and then
Okay.
they'll be transferring to CSUB. So we know that this is all about students, and we care about our students, and we wanted to welcome them to our beautiful campus.
Well, it certainly looked as though it was off to a very good start.
Very smooth
and
start.
talking about, so you've got students working on their associates and then getting ready to transfer full-time into CSUB. Let's go even back a little bit farther. There's a strategic plan
Yes.
that CSUB is involved with
Right.
students even younger than that.
Absolutely. Well, we're working on the Kern Pledge with our collaborators in Kern County, and we're really happy to be working with our superintendents, also our community colleges, and then our four-year institution, CSUB. And in that pipeline, we're again trying to reduce barriers to make sure that students that are interested in a four-year degree have that opportunity. And we're really proud of the academics all along the pipeline, and that we're also really making headway with those students getting great jobs in Kern County. So the majority of our students that graduate from CSUB stay in Kern County to work and serve.
And that is key, because there are a lot of industries now where they can stay in Kern County, where that may not have been the case a number of years ago.
Yes, we're proud to say that 70% of our alums stay in Kern County to work and serve.
I being one of them also right there, right?
There you
So,
go.
There you go,
There
right?
you go.
So speaking of awards and things like that, U.S. News and World Report at the beginning of the year
Yes.
awarded CSUB
Yes.
with a pretty nice award.
It was amazing. This is the first time we've been recognized in U.S. News and World Report. We were recognized for our social mobility, and what that means is we provide a great education. It's a quality education at a very affordable price, and that our students are getting amazing jobs. So that social mobility means that they are coming into an education that is going to give them mobility, and they're going to get jobs that, again, are going to make their families proud and change the trajectory of education in their families.
Which is one of the reasons we like having you on, as well as other people from the community, to let them know what services you provide for students
Right.
through your location.
Absolutely.
And one of the things, I know a lot of students, because we bring students to CSUB a lot on field trips to get them introduced to the
Yes.
campus at a young
Yes.
age. One of the things that students oftentimes, maybe they don't think about, but they kind of, it's in the back of their head, is how am I going to pay for school? Best bang for the buck
Yes.
is another thing that CSUB has
It's
been awarded
huge.
with.
Absolutely proud of that. So we were noted nationally for being best bang for your buck in the West. And what that means is that, again, very top quality education, very affordable. We also, one of the services that we give students are opportunities for financial aid. 80% of our students have some form of financial aid at CSUB, and we're there to make sure that they get to the finish line. We really are pushing getting that four-year degree. So 15 and 4 is that program, and really encourage students to think about the math of that. So if you think about getting through in 4 years, that's 15 units a semester, and that's the most economical way to move through your 4-year education at CSUB.
And there are students that are able to do that in less time, because a lot of the high schools have classes where you can count those towards
That's
university
right.
units.
That's right.
And there are students that graduate in 3 years.
We're happy to say that we're going to be celebrating students that graduate in less than 4 years, and we have so many students graduating at CSUB now that we have to have a December graduation ceremony, and for the first time you'll see those students that are graduating in less than 4 years, and we're really proud of them.
Well, you know what? You have a lot to be proud of at CSUB. And this is the 50th year for the university.
Yes,
and
yes.
there have been celebrations going on, but what's coming up that people can look forward to?
Well, one of the things we just kicked off is that we have in the library a historical archive of the 50 years. And so really welcome the community to come to the Walter Stern Library and see the archival work that's been done. So that's really the kickoff, and we're really proud that we have a large group of events that will be open to the community as we move forward to the 50th anniversary.
Now, speaking of the library, you were just telling me about this. I wasn't aware of this. Another part of the Fab Lab.
Yes.
So the Fab Lab, in case students aren't familiar with this, is it's a room.
Yes.
Where it was designed originally back east for MIT for engineering students.
That's right.
But then they saw the benefit of having other students use it as well. And CSUB is the only CSU and UC school in all of California
Yes.
that has a Fab Lab on their campus.
Yes.
So that's something to be pretty proud
It's-
of. But then talk about the other part of
It's a
that.
pride point indeed, and what we're really proud of is that that is an open lab to our community. So it encourages children, adults to come in with projects and to really work with programming to use that Fab Lab, the 3D printers. And one of the things that we heard is that our students wanted access to the Fab Lab in other locations at CSUB. So we just opened up the Fab Lab Annex in the Walter Stern Library on the 2nd floor.
I was going to inquire where that is.
And as you walk up the stairs, you can't miss it, and we'll have an engineering student, as we always do, there to help support you on your project.
Well, I know that a lot of students I bring over from 6th grade, we go to the Fab Lab, and then I bring them to the Student Rec Center and Student Union, and they go, well, when can we start doing this?
Yes.
You know, like, can we go to school now? And I go,
Yes.
well, soon enough, you'll be able to get there in a few
We
years.
love that learning by doing.
And most recently, you have just received
The Krista McAuliffe
another award.
Award in Teacher Education.
But this is a big one.
This one, well, they're all big. This one I'm particularly proud of. CSUB was recognized for teacher education. We're particularly being recognized for having our teaching out in the school districts, and it's helping with our rural school service alignment. And we were recognized in Phoenix, Arizona by the American Association of State Colleges and Universities. The only other California public school that has won that award is Fresno State. Happened to be while I was there
I was
as the
going
provost.
to say, that's where you came from. So a little something going on right there, where you must have a lot of things going on where people see Dr. Zelezny as doing some great work at the university she's at.
We're doing it as a team, and again, it's just a real pride point to be in Kern County, and I love the students that I work with and the partners.
And
to
talking about what
CSUB.
you bring to CSUB, I just want to say on a side note, is that I think everybody is very proud that you are the president of CSUB. One of the reasons being that you are always involved and visible with things going on in the community, because I mean, you're out and about in the community representing CSUB, but also at CSUB events where sometimes you may not see the president of the university, you may know where they are at, and you may be able to see them once in a while, but you're at a lot of events, particularly a lot of sporting events as well.
Yes.
Do you have a sport that I know you like all of the sports and you support all of the sports, but is there one that you like going to more than the others?
Well, let me answer it this way. I can say that one of the draws to coming to CSU Bakersfield was the fact that they were Division I. I've only ever been in Division I athletics.
Okay.
And so I can honestly say that I really do love all of the sports that we have at CSUB. I am really happy to say I'll be traveling with the men's basketball team to Ole Miss. I really love the teams that we will be playing in the last year of the Western Athletic Conference. I really expect to see some championships this year. We'll be moving into the Big West, and I think that's going to be very competitive for us as well. So all athletics are exciting and energizing to me, and they bring again a real engagement with the community to the university. So I love all of athletics. It's fantastic.
Well, you know what? We certainly do appreciate you taking out a little bit of time to come and visit us here on Do the Math.
Thank you.
Letting the students and parents of Kern County students know what CSUB has to offer, some of the things going on and some of the things coming up, and that is today's Math in the News. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year, and we'll be back with more right after this.
Hey, we're here with a little math in the real world, one of my favorite parts of the show. We want to know how math works all around us. And what better place to come here than to the Buena Vista Museum of Natural History, and here in Bakersfield, just right down the street from our studio, we have our good friend, Dave Hanley. So lucky to have you again. We always love to chat with you. We've been talking a little bit before we got on air about the math that goes behind the science. Right. So I thought maybe we talk just a little bit about integral equations because they have to do with movement of things. So, you know, students have always, they know how this works, right? They get a coin, they spin it around, there goes the coin, and it goes down pretty quickly, and you can do all kinds of little fun elementary games, and you try to stop it in mid.
I love a quarter for every student that tried to do that to make me nuts while I'm trying to do a lecture, right? You know,
a little bit tough in the classroom, but everyone can kind of relate to that. There has to be a way to describe that momentum and the fact that it goes down quickly or not so quickly. But you have something here that you can kind of show us maybe. This one doesn't go down as quickly because it's a heavier disc.
Well,
It's got less friction.
somebody made it, yeah. Now we're talking about integral equations, and the whole concept of integral equations is they're not linear.
Right.
In other words, so when we're talking about the sharks and we're talking about the other things, we'll talk about things that do not have a linear relationship with their growth or expansion, that sort of thing. It goes growth or diminishing. So in the case of this is an integral equation. We're talking about a disc. We're talking about this metal disc, very smooth, lowering the friction. This has the ridges on it. The desktop is pretty cool, but it does have more friction. There's more friction involved, so it takes a little bit longer for it to spin. This is a brushed steel. This is a glass, smooth metal mirror, concave to keep it in the center. And so this was manufactured to be able to do this demonstration. And it's called Euler's disc because there's a formula at which this is falling at an ever diminishing rate. It starts out with a greater fall, and it cuts its distance as it falls to less and less and less. Right. It would go on for infinity and never slip down if it were not for gravity. Right. So gravity is cutting into the momentum.
Okay.
And so Euler figured out the formula to determine at which point the momentum would become overcome by the gravity.
Okay, gotcha.
And so that's why it's called Euler's disc. He's got the formula. It's on the back of the box.
Sure. Now we can see this going down and down and down, but we have a different effect that we can do if we can only see pieces of it, and you do that with a strobe light, right?
Correct.
Okay.
Okay, so if we'll do the light. We'll do the strobe light. Come on. Right. There we go.
And from my perspective, it looks like that thing is completely stopped. It really is a unique look to it, and it's just taking little individual images of that thing spinning, but it's taking an image of it in almost the same place each time it goes down.
And
now
it has to do
I'm
with the
seeing
rate
it
of
change.
fall. Well, the rate of fall is changing.
Sure.
And it is. And so this is what we use to time our engines.
Right.
So this strobe effect, this is the strobe effect of the sun. If you're driving down the freeway, the strobe effect. So we're getting two for the price of one.
Sure.
We're getting the effective strobe, and we're also getting the effective integral equation. And the fact that it does look like it's changing its action is because it is falling at an integral rate. So
Right.
it did stand still for a moment,
Yeah.
but then it changed because the rate is constantly changing.
Yeah.
And now gravity is about to overcome our momentum, and it's a... Come on, slap
There
down.
it is.
There we go. All right.
So and we finally get to a flat disc there, and that's going to happen just because we have some things in this world that we can't completely describe with mathematics. But the main function of this, or the main part of...
The point is, that was Euler. Euler
Right.
described how we take gravity, the formula for gravity,
Right.
added into a typical integral equation, which is the rate of diminishing fall,
Right.
not linear, but diminishing, okay?
Right.
integral diminishing. And so he added in the factor of gravity and made it an equation where you could anticipate exactly how long with given momentum it would take before that would fall and hit.
Right.
Then I discovered, to my pleasure and amazement, the thing about neodymium magnets in an aquarium.
Sure.
And of course, the formula would fit exactly for that, for those to come to a standstill in reverse instead of down, up. But we would have to add in the force of the magnetism instead of gravity.
And that rate would change up or down depending on how many magnets you had and how wide you started the initial spin and all those factors, of which we can control in our equation if we had an integral equation, right?
Correct.
Yeah.
The patterns of science
Yeah.
in the natural world.
The power of math, unbelievable. What we really want to know is where this happens in the animal world. So when we come back, we're going to look a little bit in the museum, talk a little bit about sharks and how integral equations end up being part of their growth and development.
Non-linear growth and mass development. And megalodon.
And Megalodon. There you go. Megalodon. When we come back, we'll do that. At the moment, we got to go back to the studio.
All right, pretty big megalodon tooth hanging around David's neck right there. Anyway, we'll check back with those guys in a little bit. We do have phone tutors available until 5:30, and I know that a lot of kids are getting excited for Halloween and stuff like that, but you still have time to do your homework before you go out and do those things, and today's not even Halloween, so even better for you to have an opportunity to call. So we've got another problem for you to work on. This one actually has to do with Halloween candy, an extension from yesterday's problems. Molly's mother started out the evening with 3 types of treats: Snickers, Tootsie Pops,
Whoops.
there you go, and Skittles. So those are the 3 types of candies that Molly's mom was passing out.
Okay.
The ratio, Snickers to Tootsie Pops to Skittle packs, was 8 to 5 to 7.
Okay.
If she had exactly 40 Tootsie Pops, how many total treats were in the bowl?
Okay, so since we know how many Tootsie Pops she has, and we know the ratio of what's in the bag, we can start with what's given, which is 40 Tootsie Pops. So basically, we're trying to figure out, since it's ratios, what do you multiply 8 by to get the 40? So that, I mean, not 8, 5. I said the answer. Okay, so you're going to multiply 5 by 8 to get 40. And since it's a ratio, that means that that value is your constant of proportionality. So you're going to multiply that to the other 2 numbers. So you're going to get 64 Snickers and 56 Skittles. And the question is how much total candy is in the bag, which means we need to add it all up. And so if we're adding it, we would usually add it like this, vertically, and then 10, 6, 7. We get 160 treats.
All right, nicely done. Now, if you had those 3 totals and I had asked you to use mental math to add
Yes.
those up, how would you go about doing that, adding up those 3 numbers?
Well, I would start probably with these 2 because I know the 6 and the 4 makes 10, which is easy. And then I would just carry the 1 and it would be 120 and then add the 40 on.
Okay, so there you go. So that's one way to do it. I would probably look at it and go, all right, let's get rid of the numbers in the 1s. The 4 and the 6 make it 10. And then we can add it to the 40 to make it 50, plus the other 50 is 100, and then we get to 60. So there's a lot of different ways.
Yeah.
But it's a good exercise for students to kind of work on using some mental math. And that way they kind of can look at it and go, all right, I know it's going to be around this number, so I can
Right.
go ahead and add them up and then just verify
Then
that
they
that
can
is it.
tell if their answer makes sense or not.
Yeah, logical reasoning, right?
Right.
All right, so let's do another problem based on that number now.
All right.
So you have 160 treats.
Okay.
And let's say out of the 160 treats, you have 18%
Okay.
of those treats are going to be eaten that night. So how many treats will be eaten that night?
Okay, so if we have 160 treats and we're going to eat 18% of them, there's different ways you can do it. Just straightforward math-wise, you would usually do 160, and we want to know what 18% of 160 is. So of is kind of a keyword that you're going to multiply. And since this is a percent, we'd want to use its decimal format, and we would work it out like this: 160 times multiplied by 0.18. Let's see. So then we're going to multiply it, and 8, 4, 8, 9, 10, 11, 12. Okay. Add a 0 for that place. And then, okay, add it up. Wait. Yeah,
You're correct.
decimal. I was like, wait, that's too big, but then I realized there's a decimal I have to put in there. Okay, so then we count, and we count that back twice. So 28.8, which means really 28 or 29, since it's candies. You can't eat, well, I guess you could eat 0.8 of a candy and throw the other part away, but that'd be silly.
You have Skittles bag, right? So you take 0.8
There you go,
part
you
of it
save
or
a couple.
something, right?
Yeah, there you go.
I was going to say, you know, when I saw you started doing that, I was like, hey, would you like to tool the calculators right here? But
Well, that one's not too bad without a calculator.
all right. So you can see if you wanted 18% of that 160 treats, it would be 28, and you round it, you would have 29%. We'll be back with more right after this. Today we're at Fraser Park Elementary School, home of the Bobcats, and we're here to We've got some fourth grade students from Fraser Park Elementary School. We've been doing some games where they started with 56, had to work back but not take the last one, then did it with a strategy using multiples of 5. Then we went from 1 to 21 with the same purpose of trying not to land on the 21. So those will hopefully help you out with this game, all right? This is called NIM. Have you guys ever played NIM before?
No.
Here we go.
I've heard of it.
You've heard of it?
Yeah.
Big day, we're going to play NIM, all right? You can see that there are 3 rows. There's a row of 3, a row of 5, and a row of 7. So that means there are how many tokens altogether on here? How many markers are on there?
15.
15. Okay, so keep that in mind as you're playing, okay? In NIM, you may only take 1 or 2 markers off the board, okay? It doesn't matter where you take them from. If I take 2 markers, it doesn't have to be these 2 right next to each other. They can be anywhere. I could go like this and like that and take 2 off. It doesn't matter where you take them off from, okay? If you'd like to take 1 off, that's fine also. You don't want to be the person to take the last one off, okay? Same as before. You guys got it?
Yeah.
All right. So the person on the left went first last time, so now the person on the right will go first. Let the games begin. All right, you're up. You can take 1 or 2 off. And remember, it doesn't matter where they're at. You may take 1 or 2 off. Now remember, there's only 15, so you want to start thinking really early about what your strategy is going to be, how you make the other person get stuck with the last one. That's a wise move by only taking 1, because now you've left me with 3. But can you see if there's a way I can win at this one?
2.
Right, see, if I take 2, then you have to take that 1. But if I go like this, what can you do now? Just take 1, right? Because sometimes people are going, well, I'll take 2 no matter what, right? Because if you had to take 2, then you would have lost on that one. So you got that first round. All right, set them up again. Now you won the first game.
Yeah.
What were you thinking of? Did you have a strategy as you were doing this?
So I think she would take 2 away, then I had to take the other 2. But she only took 1, so I took the other 2, and she had to get the other 1.
So you kept taking, so that whatever she took, you made sure there were 3 left.
Yeah.
So when you take 3 at a time, because 3 is, right, you're going to be able to work into 15, right? So now the other person goes first. And we'll see if your strategy still works, all right? Or if the other person does something a little different. All right? I'll go with that. This is going to make it more difficult. Are you guys ready for that?
Yeah.
Okay. I kind of thought you were. You know you can take 1 or 2 off.
Yeah.
If you take 2, they must be from the same row. So if I take 2, they have to be in this row or this row. Okay, I can't go like this any longer because they're not in the same row, are they?
No.
So if you take 2, they must be in the same row. Go ahead and start. Now we're getting down to the end here. You may take 1 or 2. If you take 2, they must be from the same row. I got stuck with the last one right there, right? So do you guys like that one? So it makes it a little more difficult that time where if you take 2, they have to be from the same row. And that, another game, little strategy, mathematical reasoning with the 4th grade students at Fraser Park Elementary. And those students certainly were fun to work with at Fraser Park Elementary School. We do have phone tutors available until 5:30. In the meantime, we're going to go over another equation for some students that are working on those. And here is the problem. Cindy, if you would be so kind. This one, not as lengthy as the last one, where we don't have any parentheses.
Okay.
So 20n plus 84 minus 8n is equal to 0. And the
Okay.
reason I chose that one is because students will look at that and go, well, 0 is 0.
Yeah.
And then so a lot of ways we can do this.
So what that pretty much tells us is the value of all this together has to be equal to 0. Okay, so if we start off and we notice there isn't any parentheses, so we don't have to do distributing. So we're going to go ahead and we're going to combine our like terms. So we're going to combine our 20n with our negative 8n, and that will give us 12n plus 84 still there equals 0. And then from there, the steps are, we're trying to figure out what goes here so that when you multiply it by 12, and then it adds to 84, it has to equal 0. That kind of gives me an idea that that's probably something negative because 84 is already above 0, and I have to make it decrease by some amount. So that's just a way of thinking, okay, I know what to expect, so I'm going to subtract 84 to both sides so that I can get the 12n isolated by itself. And then 0 subtract 84 is the same as 0 and negative 84, so it makes negative 84. And then we're going to divide by 12. So that's the inverse operation of the multiplication right there. And we get n equals negative 7. And then if we want to check it, we're going to plug it back in. So let's just check and see. So if we do 20, it's going to multiply by negative 7. And then plus 84, subtract 8 times negative 7. And
That's pretty
just
slick how
equals
you can
0.
change colors
It's
mid-sentence.
like magic. I don't know how that even happened. Okay, so then when we multiply these for order of operations, we get a negative 140. And then we still have our 84 because we're not adding yet because that would not be correct order of operations. And then we want to do negative 8 with negative 7 multiply is positive 56. Look, it did it again. Must be that spot on the board. All right, and then we're going to go ahead and just add this up. So I'm going to add these first just because they happen to be both positive. So that's 9 plus 140. And negative 140 plus positive 140 does equal 0, so we know it worked.
There
so
you
our
go.
answer is -7.
There you go. And that's always important for students to check the problem. That way they can verify that it is indeed correct.
Absolutely.
Especially if they get a number that is sometimes negative, might throw them off, or if they get a 0 as an answer. 0 is a number, and it can be an answer, so it's always good to check the problem. All right, we'll head out one more time. Check out what the boys at BV Museum are up to.
We're back with some math in the real world, and this is our world this afternoon. We're here with Dave Hanley, and Dave, we know, if we've been in Kern County at all, that there are a lot of shark's teeth around this place. There's a place called Shark's Tooth Hill. I know that it's been part of my experience as a camper and all that fun stuff, and we were talking earlier about integral equations. So let's put those two things together. We have a big fossil bed here in Kern County, and we have integral equations that can describe certain things, growth patterns in nature, right?
Right. We have the largest Miocene fossil bed in the world here in Kern County. And the Miocene, 12 to 17 million years ago, is 5 million years.
Okay.
And it's going to be one of the summative things that we're going to do too.
All
It's about the
right.
teeth that are in the Shark Tooth Hill Formation.
Okay.
It's called the Shark Tooth Hill Formation because of the teeth, because sharks' teeth are Rolodex. And some of us older people know what Rolodex is. A lot of the younger people don't know, but that's where you have all the cards and they keep rolling forward. And so the teeth keep rolling forward. The shark may lose as many as 1,000 teeth per year. And when you consider that we were here for 1 million years, at any point in time there was 1 million sharks in the water, and 1,000 teeth per year for 5 million years with a million sharks. There's a whole bunch of teeth down there in the largest Miocene fossil bed in the world. It happened to be at the time of the megalodon shark. So when I tell people that we have the largest Miocene fossil bed in the world in Kern County, that's ours. They come from Germany and Japan to see our fossils. And so this guy was around then, he was popular then, they want to find out about megalodon, they come to Kern County because we've got the best examples to show them.
Sure.
Okay, so here's the megalodon shark. He got up to 60 feet long. Imagine the really big school buses. Put a 6 foot by 6 foot jaw on the front of that bus, and it gives you an idea how big that shark was. He was a huge predator. That was a giant predator. They snacked on baleen whales. They snacked on adolescent baleen whales. They snacked on alodesmus sea lions, like elephant seal-sized sea lions.
Oh, wow.
Now, let's not mess around with little seals. Those things would be a little... So anyhow, well, it's the same relationship. You know, again, we're talking about non-linear growth patterns.
Okay.
Okay, so I had Burmese pythons hatched out in my classroom. Okay, they hatched out at 18 inches. At 18 inches, they were approximately 8 ounces.
Okay.
By the time they were now twice that, which would have been 3 foot, now all of a sudden they're like 5 pounds. So the growth rate is not linear.
There you go.
It's an integral equation. It's a logarithmic growth pattern.
Okay.
And so now we talk about megalodon shark, and they were live bearers because they had internal fertilization. The mother would be able to keep the babies on board, didn't have to dump a whole bunch of eggs down. The mothers would be able to have the baby inside.
And this is a representation of a live
This would have been the
shark
the
at
size
birth.
of newborn at birth
Wow.
megalodon shark. It would have been about 6 foot long, weigh about 200 pounds.
Wow.
Now, at 12 feet, we're talking about 1,000 pounds. We're not talking about
so
400
double in
pounds.
size, but definitely more weight
Way
to it.
more, 2.5 times.
Yeah.
Okay, so we're talking about integral equations, we're talking about logarithmic growth, we're talking about non-linear growth patterns, and that's typical of snakes, that's typical of sharks, that's typical of whales, that's typical of, just everything in the living natural world.
Sure. Wow. Now, do the teeth growth, you were talking about the Rolodex part, does that have any kind of integral relationship at all about how fast they grow or how fast they're gone, or is it matter
I
what they
understand
eat?
we might be doing another segment in a little bit about a summative relationships. And so this becomes a summative relationship because if we're talking about 5 million years,
Right.
at any point in time, 1 million sharks
Sure.
losing 1,000 teeth per year because of the Rolodex teeth, they're constantly moving
They
forward.
just keep on generating.
This tooth was one of 3 we found in the skull of a adolescent baleen whale that we were excavating.
So that's how you know they ate those.
Well, they come off as they eat.
Sure.
And so they don't die to leave their teeth behind. A whale dies to leave a tooth behind.
Okay.
A sea lion dies to leave a tooth behind because they're mammals. Sure. But sharks, they don't die to leave it behind. That's why it's called the shark tooth hill formation. So look at the summative equation. You want to figure a number that you can't calculate, you probably can't even describe.
Right.
It requires a thing that we use called summative equations.
Okay, gotcha. So we have a lot more math to do. Wow, it's so exciting. I love to see the fact that we can see the math going on in the natural world, and I love to have you explain that to us, so really, really appreciate that.
Science
Yeah.
is not about knowing. Science is about discovering the patterns in the universe.
Right.
And the best universal language for that just happens to be mathematics.
Ah, such a shame. Well, heck, let's make a show about it. Oh, we have a show about it. All right. So when we come back, we'll do some summative work. We'll talk a little bit more about integral equations. But right now, I know we have some important math to do back in the studio.
All right, thanks for that, guys. That would be pretty amazing. See a 6-foot, 200-pound shark, newborn, just born, coming out already that size right there.
Crazy.
Anyway, we do have phone tutors available until 5:30. Cindy is right now going to work on a problem. Percent increase is something that you're working on in class. So explain to us a little bit about what the students need to know in order to solve a percent increase problem.
So if they're trying to find the percentage that something increased by instead of just the amount that it increased by, first they have to figure out how much did it increase by. So
All right,
they know
so
what the
let's
change
go ahead
amount
and do a
is.
problem, and we'll
And then they use that
see
to
what it
figure out
was.
the percent. All right, so gas prices have been really crazy lately, right? What do you remember them being like, say, 2 weeks ago?
I
Three
remember
something,
it's
right?
always been around $4, so I remember
It was a
that.
little
but it's
lower
a
than
little
that, though,
high,
right?
a little high in the $3 range.
Let's say it was, I don't know, they like 9, so let's say it was $3.89 per gallon for regular, right? Regular unleaded. All right, and then right now, depending on which gas station you go to, of course, but if you go to most of the gas stations, it's at least $4.19, $4.29.
Let's make it $4.19.
All right. And that's just within the last couple weeks, right? So that's a definite increase. And if that continues at that same rate, we are all doomed, right?
But it's going to continue
Okay,
for a
so
little
if we
while.
want to figure out what percent this is, then first off, we're going to have to figure out how much did it change by. So your first step is you want to subtract the values, and we're going to start just with the larger number. So 419 subtract 389, and then when we get our value, so that's 30 cents. Okay, so it changed by 30 cents per gallon, but that's not a percent. So if we want to know what the percent is, there's different ways you can always do a math problem. The way we've been working on in class is using proportions, because we just finished our chapter on proportions. So we use a proportion. And basically what happens is we don't know the percent, so this is our variable. And over here, what we need is we need to know, what did it start at? So it originally was 389, so that's going to be our denominator. And then how much it changed by, the subtraction amount, is what we put on top. So 30 cents. And then we can calculate the percent using the proportion. And so how you solve a proportion is by cross multiplying. So you multiply 100 with 0.3, which just gives us 30. Okay. And then we multiply this side, $3.89 times x, so 3.89x. And then it's just a one-step equation where we just have to divide to get the answer. So we want to divide by 3.89. And luckily, by 7th grade, you get to use calculators.
Here you go.
So
Use the tool today.
So we're going to use a calculator. So we're going to divide 30 divided by 3.89. But that does bring up a good point of you have to know how to put it in your calculator. So the top divided by the bottom, and you get 7.71208. So we're going to go ahead and round it to the tenths. So approximately 7.7% or almost 8% increase in just the last couple weeks.
All right. Well, you know what? It'll be hopefully fun when it goes up another 8% in the next couple of weeks.
That's what
and
I'm worried
things like
about,
that.
if it keeps moving.
Yeah, nobody likes that at all. All right, erase the board. We have a great problem for you to work on. And the reason I want you to work on this is that a lot of times we do 4-4s with the students, but we're going to talk about some of the other operations that some of the students may not be familiar with when they're doing this problem. So let's go ahead and put 4-4s up on the board. So most of the students are familiar with this problem if they've been viewing the program over the last few weeks. You have to use 4-4s, and you have to use all 4 of them to equal up a number that the student would come up with. So most of the students are familiar with add, subtract, multiply, and divide. So obviously you can use all of those.
Right.
But then in order to group the 4s to make things a little bit easier. Using factorials, square roots of 4, things like that is what we're going to have Cindy work on today. So Cindy, how many class periods do you have every day?
7.
So let's make it equal 7.
Well, do you mean including lunch?
Well, if you want to make it 8, make it 8.
7 not including lunch. 7's fine.
You want to go with 7?
Yeah.
All right,
Well,
so
do I?
use the 4 4s to make them equal to 7.
Okay, so if I want to make it equal 7, and based on what I have right now, I'm going to start with just basic numbers because, I mean not numbers, basic operations just to see if I can make it equal 7 with basic things. So if I add, I get 8, and then if I add again, I get 12, and then if I subtract, I get 8. Oh, I should have made it be 8. It would have been easier.
Well, then you would have had to do another one.
So I know that somehow I got to get a 1. So I definitely know, I can get it. And the only reason I say I need to get a 1 is because that's not a multiple of 4, it's 1 away. So I might maybe divide to get a 1 between 2 4s, but I still need to figure out how to make the other part. What would that have to equal then? 6? Yeah, that's not going to happen, right?
Well, that's if you want to go
If I was
from
just
down to go up
thinking
1,
process, right? So,
And you could do it that way.
okay, let's see.
So
what
there's a way that we could add 1 to get 7, and there's a way that we could subtract 1 to get 7.
True.
So I'll let you decide which way you would like to do it first.
Oh yeah, if I subtract, that's way easier, huh? Okay, so I can make this divided, and this plus, and then this subtract. So, because order of operations, I would do this first, which is 1, and then this adds to 8, and then subtract 1 equals 7. Oh, yeah.
There we go. So now let's talk about order of operations. Don't erase anything.
Okay.
Because if a student did not understand order of operations, they could see that that would come out to be something different.
Yes.
What would it be if they did not understand order of operations?
So the common error that they would make if they didn't already learn about order of operations is they would just want to do it kind of like they read a book, just straight through the problem. So they would add 4 plus 4, which is 8. 8 subtract 4 is 4, and 4 divided by 4 is 1. And then they would write that it equals 1.
Right. And if they grouped it a certain way, you could do that.
You could make it equal.
Right.
Yeah.
So let's get rid of the 8 minus 1 equals 7.
All right.
On the second row there, we'll just erase that part. And I guess you can get rid of the little lines connecting there you go. We'll leave that problem up there, and then right under it, put 4 4s is equal to 7 again. But this way, we'll put other symbols in there. And instead of subtracting 1 to get 7, let's add 1 to get 7.
Okay, so the only way I'm going to get my 1 out of there is with some sort of division. It probably doesn't matter if I put it there. I'm just going to put it there because that's where I had it last time so that I can think of how I'm going to make this equal 6. Because I want to add 1 to something to get 7, and I know that this would have to equal 6. So this is where some of those other values that aren't as common come up for elementary school. So one of the things that you'll learn is square roots. So basically, a square root, like the square root of 1 is 1 because 1 squared equals 1. Square root of 4 is 2 because 2 times 2 is 4. 2 squared is 4. Square root of 9 is 3. 3 squared is 9. So I know that if I put a square root symbol around one of these, I'm going to get a 2 out of it. And that's what I need because if I add it with the 4, 2 plus 4 will give me 6. So this would now give me a value of 7 in a different way. Square root of 4 is 2. Oh, I should have started here, huh? That's 1. Then I'd go back here. Square root of 4 is 2. Plus 4 plus 1 equals 7 because 2 plus 4 is 6 and 6 plus 1 is 7.
There you go, nicely done. Now, let's erase the last 2 lines, leave the one where you started off with the square root.
Okay.
And this time, what I'd like you to do is once again, add 1 to get 7. So there's another way, because instead of the square root of 4, let's try and introduce the students to factorial.
So take the square root off?
So we're going to go 4 times 3 times 2 times 1 would
So,
be 24.
okay, so you want me to take the square root off, right?
Right.
And then you want
Well,
me to...
you leave the square root symbol
Oh,
up there. Now
okay.
we're going to make another row. So
Oh,
we'll make
we're
4
gonna make a
4.
new
Right.
problem.
New
Gotcha.
row. So 4 4s again.
And we want to make it equal 7 still?
Right, and we want to add 1 again at the end.
So we still want a 1 at the end. Okay, so we still want this to be division, so it's 1.
And we still want to add 1, so we're going to have to get 6 with the first 2 numbers, but using factorial for one of them.
Okay, so what a factorial is, if I make, say, this one 4 factorial. So 4 factorial looks like an exclamation point. And what it means is that you multiply the number itself with every number lower than it down to 1. So this was equal to 4 times 3 times 2 times 1. So 4 times 3 is 12. 12 times 2 is 24, times 1 is 24. So 4 factorial is equal to 24. So if I make this be a factorial, then I know its value is 24. So then I would try to ask myself, okay, what do I do with 24 and 4 to make it equal 6 so that when I add 1, it still equals 7? So that would tell me I need to divide it, because 24 divided by 4 is 6. And I know this whole thing equals 1, and then we add the 1 to the 6, and we get 7. So this, if I were to work it out, it would look like this: 24 divided by 4 plus 4 divided by 4. And order of operations, I would go ahead and do this division, and then I would do adding. So I'd get 7.
There you go, nicely done. So I know now we've done 3 different ways to get 7. How many other ways do you think there are to get 7?
Gosh, I don't know.
There are a lot of ways, but lucky for you, this is only an hour-long program, so we'll let you ponder on that for another moment. We do have phone tutors available until 5:30 this afternoon, and we'll be back with more right after this.
I know you couldn't wait to come back to the Buena Vista Museum of Natural History here in Bakersfield. We have some math going on in the real world all around us, and Dave Hanley is going to show us a little bit more about integral equations. What a wonderful way to explain to students how we can make things increase, but then not increase at the same rate. The rate changes. So tell us a little bit about this experiment that you show your students, which I think is a wonderful way to show that relationship.
Okay, so absolutely, this one's kind of fun. I like candles. I like burning things. Students like burning things.
Right,
Anything
yeah,
burning
it
is
catches
always
their
fun.
eye.
And so if you notice in here, we have actual one real candle, and this is an optical illusion sort of thing.
Right.
And so we see that we have visually we see at least 4 candles.
4 candles.
Now I'm sitting here playing with the idea, since it now has a flame on it, I actually see 7 flames.
Oh, interesting.
But that's just an added little thing, just for
Right.
the sake of
Right.
complexity. And,
Right.
and
But if we're looking at it from this angle here, we can see 4, 3 in the mirrors, and 1 real one right in front of us, right?
Right.
Okay,
I
so let's-
had to add that. I'm sorry.
That's all right.
That's mean. Okay, so now I'm going to change the angle in here. This is a 90-degree angle. I'm going to change the angle by about 24 degrees.
Okay.
So I'm going to change it by about
So
12
now
on
the
each
walls
side.
are closing in.
So we got a change of about 12 on each side, which adds up to a total of 24.
And
And-
now we seem to see more candles.
See 5 candles?
5 candles, yeah.
Okay, I'm not writing lines to see, but I'm trusting you.
Yeah,
Okay,
I see
now
5. There you
now
go.
I'm going to change each of the wings by 6, which is half of the original change. So I'm going
Right.
to change this by about 6 degrees,
Right.
and now I think we're going to have way more candles.
Yeah, that's right. I mean, I
Okay.
can see 6 at this point.
And
yeah.
so now, if I change it by 3 degrees on each,
Mm-hmm.
then we'll change it even more. So you see, what we're doing is we're describing the purpose of science and mathematics is to describe the patterns in the universe.
Right.
And so this is we now have a relationship between the changes in the angles.
Right.
And it's in geometry, but it's still an integral equation, so it's still algebra, but it's still geometry, but
That's
it's
right,
still.
'cause we
it's
can't
all-
describe that
Oh,
with
it's
a
all
linear
just
relationship.
mathematics. I'm a non-denominational science mathematician.
That's a wonderful example of a way to show that we have a relationship, a direct relationship, but it's not linear. So I like that one a lot. Now here's one that I think is the most amazing. We talked a little bit about amino acids and how they come together to make proteins in our bodies, right? But we have some proteins that have two or three or 4 amino acids, and some that have a whole lot more than that. Tell us a little bit about
Okay.
the building blocks.
We're
of
really
proteins.
proud of ourselves as humans. We're Homo sapiens, which means in Greek, human ideal, and we ain't close. I'm
Okay,
sorry.
all right.
But here's what we've done. We've done computers.
Right.
We're really great because we've done computers.
Sure.
Nature has this computer way beat. We got us
okay.
totally beat on a computer.
Yeah.
We started out with a computer program.
Right.
Where with our computer programming, we started with binary. Okay.
Yeah.
So we go nine in a row. So what is a bit, a byte, whatever? 9 in a row, and so 1. That's 1. this is 2,
Right.
this is 3, and so forth.
And so each of these places either on or off.
Right,
And
exactly.
so if you're trying to get some information through, this would be a long way to do it. You could do it, but it would be a long way to do it.
They had
Take a
whole
while.
rooms full. Now they do it with the little silicon things, and they positively or negatively charge the silicon things on and off. Now they can do null, positive, or negative, and now they're up to a trinary, and that's really choice. But nature.
Nature's
Mama
better
Nature.
at this. All right, tell us what
Okay,
we're going to do here.
so what Mama Nature has done is she's done all the processes and stuff that we want to do with computers, only with living things, and she's done it with proteins and amino acids.
Right.
Okay, proteins are defined as 2 or more amino acids joined together.
Right.
And all of those proteins do all of the functions of all of the living world.
Okay.
And so that's what we do with computers. We do functions with computers. We do functions with living things. And so that's what Mama Nature does. So here's what Mama Nature's done. She says 2 or more amino acids. Now there's 20 amino acids. So we have over here, we have the chart. I've got this over here. I did a quick little add up of it. So that in the chart here, we've got 20 of these are the stop codons. So they tell you when to stop making a protein. So they don't count, but all the rest of these 20 are all proteins. They're on this chart, or amino acids, and they're on this chart, and triplet coding in the DNA transferred to the RNA gives us the amino acids that are joined each time in each of those steps.
Okay.
So now, if we go back over here, we understand that there's a protein in our arm, a fibril protein in our arm that takes 1,332 amino acids.
Wow, that's where this number comes from.
So
And you
this
said
is-
that it has to have at least 2.
It has
so
to have at
somewhere
least
between 2 and 1,332. We're in
That-
there somewhere.
That's in there. So the way we figure out how many possible proteins there are in the living world is these are the building blocks. These are the processes. So we got a few processes we get to do.
Sure.
We start with 2 to the 20th power because that's the number of proteins we can make with 20 amino acids. 2 to the 20th power is how many proteins with 2 amino acids.
Sure.
Then we get to add that to 3 amino acids to the 20th power. Then we add that to 4 amino acids to the 20th power, and 5, and so forth until we get down to 1,332 to the 20th power. And one of my students says he did it right. I'm not sure whether he did it altogether correctly, but he tried doing the summative on this, and he came up with 8.65 times 10 to the 76th power. That would be 8 with 76 zeros behind it, or
Right.
74 zeros with 6, 5, 7, and
Sure.
74 more zeros behind it.
Just a small number in nature.
I don't know how to name it.
We don't even know what to call this number. That's right. So Mother Nature has done math way before we thought we could understand it all. And
Computing.
computing. That's right.
Computing.
Yeah.
This is the computer we want to build.
Right. Yeah,
Yeah.
that's it. Boy, and be able to do something, crunch the numbers like that, it'd take a little longer than recess to make sure you have all those numbers, right? There you go. We're so grateful to have been able to speak with you today. We're so always amazed to see all the math that's around us, and what a better place to be than here at the museum. Thank you for your time.
Oh, my pleasure. Thank you. It's a pleasure. I love
Yep.
it down here. This is what we're about.
That's it. That's it. So come on down to the museum if you want to see a little bit more about math in the real world, a little bit math in the natural world, but I know right now we have some more math to do back in the studio.
All right, thanks for that, guys. And, well, no more math for today because our hour is up. But we do have phone tutors available until 5:30 this afternoon. The phone numbers are at the bottom of your screen periodically throughout the program. I did get that out right, didn't I? Sounded like I don't know. Anyway, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.